Welcome to this video. In this video, we are going to learn about the chi-square distribution. In this video, we are going to learn about the chi-square distribution. That's chi-square distribution. We have three cases. One is chi-square test for goodness of fit and test for the population variances and test for independence of attributes. Now, the properties of chi-square distribution. The exact shape of the distribution based on the number of degrees of freedom. In general, where n is the small, the shape of the curve is skewed to the right and the degrees of freedom gets larger, then the distribution becomes more and more symmetrical. The mean and variance of the chi-square distribution is n and 2n respectively. When n tends to infinity, the chi-square distribution approaches to the normal distribution. The sum of independent chi-square variates is also chi-square variates. Uses of chi-square distribution: to test if the hypothetical value of the population variances is equal. If the population variances are equal, then we want to test by using chi-square test. To test the goodness of fit also by using chi-square distribution. It is used to determine whether an actual sample distribution matches the known theoretical distribution. Third point, to test the attributes, independence of attributes. And fourth one, it is used to test the homogeneity of independent estimates of the population correlation coefficient. That is, chi-square distribution is used to find the goodness of fit and independence of attributes. For solving chi-square distribution, we want two set of frequencies. One is observed frequency, another one is expected frequency. The first one, it is used to find the goodness of fit. If OI represents the observed frequency with n set of values and EI represents the expected frequencies, that may be theoretical or hypothetical frequencies, where I varies from 1 to n, then the statistic of chi-square is defined as chi-square is equal to OI minus EI the whole square divided by EI. That is, observed frequency minus expected frequency the whole square divided by expected frequency, and degrees of freedom for chi-square under goodness of fit is n minus 1 with respect to one sample. Next one, note, degrees of freedom for fitting of curve under binomial distribution means n minus 1, for Poisson n minus 2, for normal n minus 3. Depends upon the distribution, degrees of freedoms are varying. Okay, now we are going to solve the problem based on chi-square distribution under goodness of fit. The following table gives the number of aircraft accidents. The following table gives the number of aircraft accidents that occur during the various days of the week. Test whether the accidents are uniformly distributed over the week. Okay, the days are Monday to Saturday and the corresponding number of accidents are given: 14 on Monday, 18 on Tuesday, 12 on Wednesday, 11 on Thursday, 15 on Friday, 14 on Saturday. Here the number of accidents are uniformly distributed over the week. Here the given data are the observed frequencies. That is, OI is equal to 14, 18, 12, 11, 15 and 14. Now we want to calculate the expected frequencies. That is, expected frequency is equal to total number of frequency divided by number of days. But total number of frequency is taking sum of all these values, 14 plus 18 plus 12 plus 11 plus 15 plus 14, we get 84. Total frequency is 84 divided by number of days. Here the number of days are 6. Therefore, the total frequency is total is 84. It's the total frequency value is 84 and number of days is equal to 6. Therefore, our expected frequency is total number of frequency divided by number of days, that is equal to 14. Okay, next we list out the corresponding observed frequency 14, 18, 12, 11, 15, 14 and we calculated our expected frequency like this 14. 14 is distributed to all, that is called uniformly distributed. Okay, now the calculated sigma square is, now we calculate the now we calculate the chi-square statistic, that is equal to observed frequency minus expected frequency the whole square divided by expected frequency. Now we get the calculated value of chi-square is 2.14. Here the degrees of freedom is n minus 1. Here 6 data are given, 6 minus 1, therefore degrees of freedom is 5. Here only 6 data are given, therefore degrees of freedom is 6 minus 1, that is 5. Next we choose the level of significance. Level of significance is alpha is 5% level and then we calculate the table value for chi-square distribution. Okay, table value for chi-square distribution at 5% level of degrees of freedom is 12.59. Now we choose the level of significance alpha is equal to 5% and then we calculate the critical value chi-square distribution table value for the degrees of freedom is 5, at 5% is 12.59. Now comparing tabulated value with this calculated value, our calculated value is 2.14, tabulated value is 12.59. Now comparing these two values, calculated value is less than tabulated value. Okay, already we know that calculated value is less than the tabulated value of chi-square means H0 is accepted. That is H0 is accepted. That is our H0 is, there is no significant difference between the H0 is, the accidents are uniformly distributed over the week. Second uses of chi-square distribution for independence of attributes. Test for independence of attributes. Let us consider two attributes A and B. Given A has attributes of, a given attribute A can be divided into subclasses A1, A2, etc. AT, and similarly attribute B can be divided into S classes, that is B1, B2, etc. BS can be divided into subclasses B1, B2, B, etc. BS. Now clearly when both attributes A and B are taken into account, each one of the classes A1, A2, etc. AT would be divided into a number of subclasses according to B1, B2, etc. BS. Such a classification is called manifold classification and a table is called S by T or S cross T or S by T contingency table. That is, the attributes A can be divided into T subclasses, attribute B can be divided into B 1, B2, etc. BS subclasses. The corresponding observed frequencies are denoted by O11 first row, first column, first row, second column, O12, etc. O1T. Similarly, second row values and so on. The last S column is S row is 0 S1, 0 S2, etc. 0 ST, and the total sum values are row total gives the B1, B2, etc. BS, and column total gives the A1, A2, etc. AT, and overall total frequency is capital N. Here capital represents the total frequency, Oij is the ith row jth column of observed frequency, Eij gives the ith row jth column of expected frequency, and Eij is calculated by using this formula, row total of B into column total of A divided by N. Under independence of attributes, degrees of freedom is S minus 1 into S minus T, S rows, N that is T columns. Therefore, the degrees of freedom is denoted as S minus 1 into T minus 1. Similarly, we have chi-square value for 2 by 2 contingency table, that is 2 by 2, S equal to 2, T equal to 2 rows and 2 columns. In a 2 by 2 contingency table, the frequencies are A, B, C, D. Then the value of chi-square is equal to A plus B plus C plus D into the cross product AD minus BC the whole square divided by A plus B, A plus C, C plus D, B plus D. Okay, this is the formula for computing chi-square distribution for independent of attributes under 2 by 2 contingency table. Okay, this is the formula for computing chi-square distribution for independence of attributes for 2 by 2 contingency table. Okay, now we are going to solve some problem based on independence of attributes of chi-square distribution. First problem. The following table gives the classification of 100 workers according to their genders and the nature of work. Test whether nature of work is independent of the gender of the work. Okay, first we set up the null hypothesis and alternative hypothesis. H naught. First we set up the null hypothesis H naught. That is, nature of the work is independent of the gender of the work. That is, there is no significant difference between them. There is the nature of the work. Nature of the work is not independent, that is dependent of the gender of the work. Okay, under H naught we want to calculate the expected frequency. Before that we want to calculate the total values for row wise total and column wise total. Column wise total. Next we set up level of significance. Next we set up level of significance, alpha is equal to 5% level. Alpha is equal to 5% level. And we know the formula for test statistic, that is OI minus EI the whole square divided by EI. Now we want to calculate the each term of EI. The total sum is row wise total and column wise total gives 100, that is our capital N. Okay, next to find the expected frequency, that is the position of E of 40 or each values 20, 10, 30 we want. First take E of 40, row total into column total divided by n. Row total value is, that is 60, and column total is 50 divided by 100. Simplifying this, we get 30. Similarly, E of 20, row total is 60 into 50 divided by total number of frequency 100, that is 30, and E of 10 is equal to row total into column total divided by total number of frequency 100, that is 20. Next, E of 30 is equal to 40 into 50 divided by 100, we get 20. Therefore, the expected frequency for each position 30, 30, 20, 20. We got it now. Next, calculate the test statistic. We know the formula for test statistics. Next, OI minus EI, observed frequency. These are all the given observed frequency. This is O1, O2, O3, O4. That is observed frequency. Now, 40 minus 30, we got 10. 10 square is 100 divided by EI. EI value is 100. That is, each position is 30. So, similarly, for the remaining, we calculate it, and simplifying this, we get 16.67 for the calculated value of chi-square distribution. Next, our degrees of freedom is two rows, two columns. That is S minus 1 into T minus 1, that is equal to 2 minus 1 into 2 minus 1, we get 1. Therefore, the degrees of freedom is 1 and corresponding tabulated value is 3.841. Now, comparing these two values, calculated chi-square with tabulated chi-square value. Here, calculated chi-square value is greater than the tabulated value. So, we accept H1 at 5% level. Comparing these two values, we draw the conclusion. Calculated chi-square is greater than tabulated chi-square. So, we reject H0. H0 is nature of the work is independent of the gender of the work. Therefore, we accept H1. Our H1 is nature of the work is dependent of the gender of the work. Second problem, based on chi-square distribution independent of attributes. From the following data, test the hypothesis that the flower color is independent of flatness of leaf. Okay, one category is leaves, another category is flowers. But 2 by 2 contingency table arises here. Now we want to corresponding total, row total and column total and total frequency value. Before that, we want to formulate the null hypothesis and alternative hypothesis and set the level of significance. That is, flower color is independent of flatness of leaf. H1 is the flower color is dependent of the flatness of leaf. Now we assume the level of significance is 5%. Okay, now test statistic chi-square is defined as, for 2 by 2 contingency table, A plus B plus C plus D into AD minus BC the whole square divided by, okay, now we label it A, B, C, D, A plus C, A plus B, B plus D, C plus D. Now we want to calculate the row total. This is 2 by 2 contingency table. It is A plus B plus C plus D is 99 plus 36 plus 20 plus 5. That answer is 160. Next, AD minus B square, 99 into 5, 495 minus 20 into 36, 720, the whole square divided by, that is A plus C into A plus B into B plus D into C plus D, that is 135, 119, 41, 25. Now simplifying this, we get chi-square is equal to 0.498. Fine. Next, we want to calculate the degrees of freedom. Here 2 by 2 contingency table is given, that is 2 minus 1 into 2 minus 1. Our degrees of freedom is 1. Degrees of freedom is 1. Next, degrees of freedom of 1 at 5% level, the corresponding chi-square table value is 3.841. Now comparing calculated chi-square with this tabulated chi-square, calculated chi-square is less than the tabulated chi-square, so we accept H0. That is, flower color is independent of the flatness of leaf. Therefore, calculated chi-square is less than the tabulated chi-square, so we accept H0. That is, flower color is independent of flatness of leaf. Therefore, the flower color is independent of the flatness of leaf. Therefore, the flower color is independent of the flatness of leaf. Now, chi-square problem. From the following data, test whether there is any association between intelligence and economic conditions. Okay, column wise gives the intelligence condition and row wise gives the economic conditions. Intelligence condition based on excellent, good, medium and dull. Economic conditions gives good and not good. Okay, the data are 48, 200, 150, 80, 52, 180, 190, 100. Here we have 2 rows, 4 columns are there. 2 rows, 4 columns are there. So we want to apply the first we want to calculate the expected frequency. Before that, we want to set up the null hypothesis and alternative hypothesis and the level of significance. First we set up H0. Okay, we assume there is no association between intelligence and economic conditions. H1, there is association between intelligence and economic conditions. Next, we want to set the level of significance, that is alpha is equal to 5%. Alpha is equal to 5%. And degrees of freedom is here 2 rows, 2 minus 1, 4 columns, 4 minus 1, that is 1 into 3, we get degrees of freedom is 3. Next, we want to calculate the total, row wise total and column wise total we want. Okay, these are the row wise total and column wise total and total number of frequency n. Next, we want to calculate the expected frequency. Here rows and columns are unequal, so we can't apply the contingency table. At each position, we want to calculate the expected frequency, that is row total into column total divided by total number of frequency, that is 478 into 100 divided by 1000 for expectation of 48. Okay, that is 47.8. Similarly, we want to calculate the remaining position expected frequency values like this by using calculator. Next, therefore, calculated chi-square is, we know the formula for chi-square distribution, that is observed frequency minus expected frequency the whole square divided by expected frequency. Computing, we get 6.2168 and the degrees of freedom is 3. Next, tabulated value for this degrees of freedom at 5% level is 7.815. Now comparing calculated value with tabulated value, calculated chi-square is less than the tabulated chi-square. So we accept H0. That is, there is no association between intelligence and economic conditions. Therefore, we accept H0. That is, there is no association between intelligence and economic conditions.